Let's take a look at a simple example program which may run on Maria. Here is the code, and then assumption is that the instructions are stored beginning at address 100. All of those numbers are either binary or hexadecimal, so we don't use a decimal number at this moment. So at memory address 100, what is given is a load 104. In instruction, first four bits are OP code. 0001 means a load, and then remaining 12 bits are address. So 104 is the address. So in the memory at address 100, in hexadecimal code is 1104 is there. And then the next address, the instruction is add 105. Add is OP code 11, and then 105 is there. And the next one at address 102 is store is 0100 is OP code for that, and then the remaining one is a 106 address. And then the last one is a halt 0111, and the rest are all zeros. A halt, the computer program simply stops there. So if you run the program starting at address 100, what happens is load 104 is whatever data at address 104. So this is memory address. At address 104, what we have is this data, which is a binary, and then equivalent hexadecimal is 23. So load 104 means at address 104, whatever the data is, read into accumulator. So at this moment, accumulator gets 23 in hexadecimal. That is there. And then next instruction is add 105. Add means add the accumulator with the data at address 105. At address 105 here, data is FFE9. So currently accumulator has a 23, and then at address 105 we have FFE9. So 23 and then FFE9s are added together. That is stored back into a accumulator, and then store 106 means whatever is on accumulator, store it at address 106. So at address 106, the result of that addition will be stored back. So that is what this program does. So the result of this addition is a C. So here C will be stored at 000C. C means 1100. And these are all zeros. So as you run the program stops here, and prior to that, at this location 106, C is stored. That's how this program works. A little bit in detail. So let's take a look at what's happening within the CPU inside the bus and registers using register transfer location. So here's our registers, and then we assume that program counter is initialized to 100. That's starting point of execution. Assuming that, then the first thing CPU does is a fetch, and then decode, and then execute. This is an instruction cycle within CPU. So fetch means fetch the instruction. The PC program counter is holding address of the next instruction to be executed. So fetches that instruction. So contents of the PC is loaded into MAR, memory address register. So MAR gets 100, which is copied from PC. Then instruction register gets the data, which is instruction from memory at address MAR. So MAR is holding 100. So from 100, the data is read and stored into IR, instruction register. So at address 100, what we have currently is 1104. So 1104 is loaded into instruction register. That is instruction to be executed. Then fetch step ends by incrementing program counter. So program counter is incremented, is pointing to the next instruction to be executed. Once the fetch is done, then decode phase is that the instruction register, the lower 12 bits are address part, so take it to the memory address register. So here instruction register, the lower part, 12 bits is 104, so 104 is loaded into MAR. Then decode the most significant 4 bits, which is operation code, OP code. By decoding, it knows that that is a load instruction. Load means something like this. So in loading instruction, what you do is read from the memory. So from the memory, MAR is currently holding 104. So from address 104, load the data into memory buffer register. So at address 104, we have a data 23. So 23 is loaded into memory buffer register, and that is now transferred to accumulator. So finally accumulator gets a 23. So that is a load 104 instruction. Next instruction, add 105, means now in previous step, after fetching the loader 104, so program counter is incremented. So what program counter is 101 now. So fetch instruction from program counter 101, it's copied into memory address register. From that, using that, instruction is loaded. So at address 101, instruction we have is add 105, which is a 3105. So instruction register gets a 3105, and then program counter is incremented for the next instruction. Now in decode part, the lower 12 bits in instruction register is address, so that part is taken and then loaded into MAR, memory address register. So that part is a 105 part. So 105 is stored into memory address register. Now decodes what kind of instruction is in instruction register. First 4 bits is a 3. 3 means add. So CPU understands it's to do add. Add means whatever is in AC, and then add the data comes from memory. So we need to get the data. So MAR is a 105. From 105, we read the data and store it in the MBR. So 105, what we have is FFE9. So FFE9 is stored into MBR. Then add instruction means accumulator and then the ones fetched into MBR is added together, and the result is stored back to AC. So the addition result is a C. So C is now in accumulator. That's add 105. Now next instruction is store 106. Whatever is in accumulator, which is a C, will be stored in at address 106. So address 106, you will get 000C is stored, and then next instruction is halt. Program stops here. So that concludes the demonstration of a very simple program.